Imagine handing a physical key to a stranger. You expect them to unlock a single door. You do not expect them to walk through the house, open every cabinet, and take items that were never meant to be touched. This is the trust we place in modern artificial intelligence. But as these systems evolve into autonomous agents, that trust is being tested. We are moving from simple question answering to complex workflows where machines act on their own. In this transition, a silent vulnerability is growing. It is not about the model failing to answer. It is about the model accidentally taking too much information with it. Now consider this. When you ask a traditional chatbot for a recipe, it uses the text you provided. It does not reach into your personal files. But an agentic workflow is different. These agents are given tools. They can browse the web, access databases, and execute code. They are designed to be helpful, which means they often gather more context than they strictly need. Research into these systems, specifically a benchmark known as Agent Dam, reveals a startling pattern. Even the most advanced models, including those based on GPT and Llama architectures, frequently fail to adhere to data minimization principles. They use sensitive personal information when it is not strictly necessary for the task at hand. This is not a theoretical risk. It is a practical reality that occurs during complex web interactions. Here is the thing. Auditing these workflows is fundamentally different from auditing standard software. You cannot simply scan the code for vulnerabilities because the behavior emerges from the interaction between the model and its tools. This is where the concept of trust, risk, and security management comes into play. We call it TRiSM. For agentic artificial intelligence, this framework is not just about protecting the system from hackers. It is about protecting the user from the system itself. The primary theme emerging from current research is the critical need to address privacy leakage in these modern agentic workflows. We need to understand that the agent might be leaking data through the very tools designed to make it useful. To understand the mechanics of this leak, you must look at tool orchestration. When an agent decides to use a tool, it sends data to that tool. If that tool is not properly configured, or if the agent is not constrained, it can send entire documents or user profiles along with a simple query. This is why the benchmark known as Agent Tools Orchestration leaks more is so significant. It highlights that the orchestration layer itself is a vector for data loss. The agent does not need to be malicious to cause a leak, it simply needs to be overeager. It grabs everything it can access because it does not know what it should ignore. This is a more realistic assessment than simply probing large language models directly. It forces us to look at the workflow as a whole system. Now consider the challenge of visibility. You cannot audit what you cannot see. A foundational requirement for effective auditing is the ability to observe the agent's internal state and its interactions. Yet, this remains a significant challenge in current agentic systems. Most current setups are black boxes. You send a command, and you get a result. You do not see the intermediate steps where the data might have been exposed. Without visibility into artificial intelligence agents, you are flying blind. You cannot implement a mitigation strategy if you do not know where the vulnerability exists. This lack of visibility is a broader issue across the industry. It indicates a lack of readily accessible information on auditing, visibility, and security best practices for these emerging architectures. So, what can be done? There are actionable mitigation strategies available today. One approach involves prompting-based defenses. You can instruct the agent to be more careful about what it shares. However, the consensus among researchers is that this is not enough. Further research is required to develop artificial intelligence agents that can proactively prioritize data minimization on their own. We need systems that understand the difference between what they need to know and what they have access to. In the meantime, organizations must build robust trust, risk, and security management frameworks specifically for multi-agent systems. This means defining strict boundaries for what data an agent can touch and logging every interaction for review. Looking further ahead, we see a clear need for standardization. The increasing scale of artificial intelligence security problems, estimated in the billions of potential interactions, underscores the urgent need for actionable mitigation strategies. Establishing AI audit standards boards is a critical step toward standardizing security practices. Just as we have safety boards for aviation or finance, we need bodies dedicated to auditing artificial intelligence workflows. This fosters a proactive approach to artificial intelligence security rather than a reactive one. We also need comprehensive resource lists, like the concept of awesome artificial intelligence agents, to help developers find tools that prioritize security from the ground up. The reality is that the current landscape is insufficient. Significant knowledge gaps exist regarding comprehensive auditing standards. We are building complex autonomous systems on top of infrastructure that was not designed for them. The limited availability of summaries for most sources indicates a broader lack of readily accessible information on auditing and security best practices. This is why the focus must shift from just building faster agents to building safer ones. We need to treat data minimization not as a feature, but as a requirement. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.